Very often when we learn about Thevenin and Norton, we also learn about delivery of power to a load. We are often asked to find the maximum power that can be delivered and also to find expressions for the voltage drop, the current, and the power in a load. Symbulator can help you with that. Imagine, for example, this circuit, which is the same we already saw in the previous lesson. If we are asked to find the maximum power deliverable to the load, and also to find expressions for the following in terms of the load's value, which is L, given in ohms. We want an expression for the current through the load, for the voltage drop in the load, and the power consumed by the load, all given in terms of the load. So the thing is that the TA script gives us all these answers. Besides giving us, as we already saw, the Thevenin and Norton equivalents in variables VTH, INO, and REQ, we also get the maximum power deliverable by that circuit equivalent, stored in a variable called Pmax. Besides that, we get a set of answers for a hypothetical load RL connected to this Thevenin or Norton equivalent, given as functions of this value L of the load. We get, for example, the current through the load, it is stored in IRL. We get the voltage drop in the load in VRL, and we get the power consumed by the load in PRL. Besides that, you get the circuit description of this equivalent with the load, just in case you want to play with it. It's a string and it's called EQC, or equivalent circuit. So let's see an example of this. You may recall from the previous lesson, we had to find the Thevenin equivalent of that circuit. So we already have that, but right now we're interested in the maximum power deliverable, as well as the current, voltage drop, and power consumed by a source, by a load with a value of L. So when we run the TA script, all these answers are stored. There's nothing else we have to do to get it, nothing special. Just ask for the answers. For example, if we ask for Pmax, we're going to get the maximum power deliverable by that circuit equivalent. If we ask for VRL, we get the voltage drop in the load in terms of the load L. If we ask for IRL, we get the current through the load in terms of L. If we ask for PRL, we get the power in the load in terms of L. And just in case you want to play with it, here's the equivalent circuit. Boiled down to the bare bones, you have the Norton source, the equivalent resistance, and the load, in case you want to run further simulations.